Hello everyone, welcome you all to the course of Foundation Engineering. It is a first review course for the preparation of examination, and in this course I will cover all the modules as per the MACOT syllabus. So we will start the first module, that is classification, selection of shallow and deep foundations. I am Dr. Souvik Patra, Assistant Professor, Department of Civil Engineering, Swami Vivekananda Institute of Science and Technology, Kolkata. So without wasting your time, let's begin. So what is called as a foundations. So if we consider any structures, suppose your buildings or bridges or dams, so each and every structure is resting on the ground. So suppose this is my structure and this is the ground level. So this structure is resting on the ground level, and the structure itself has some load, and this load to be transferred on the ground. So we are using an element that is known as structural element, that is known as the foundation, by which we are transferring the superstructure load or the load that is above the ground to the subsoil, so that the superstructure load can be safely transferred to the soil. So it is known as the foundation. So if we want to classify foundation, we can classify it based on the criteria, that is depth of foundation and width of foundation. So basically we classify foundation in a broad category. The first one is known as your shallow foundation, and the second one is known as your deep foundation. So if we consider the shallow foundation, so this is the shallow foundation. Here, this depth to the bottom of the foundation base, we can consider it as the depth of the foundation, and it is the width of the foundation. Similarly, in case of deep of foundation, here it is the depth of the foundation and it is the width of the foundation, or sometimes we can also take as a diameter also. So the criteria by which we are classifying foundation is the df by b ratio. So df is the depth of the foundation and b is the width or diameter of the foundation. If the df by b ratio is less than equal to 1, then we can call it as a shallow foundation, and if the df by b ratio is greater than 1, then we will call it as a deep foundation. Now remember here that the df by b ratio is less than equal to 1 in case of shallow foundation, and df by b is greater than 1 for deep foundation. Further, we can classify deep foundation in such a way that if df by b is less than 15, then we can call it as a moderate deep, and if the df by foundation ratio is greater than 15, then we can call it as a deep foundation or very deep foundation. So the basic criteria is, if df by b ratio is less than equal to 1, we will call it as a shallow foundation, and if the df by b ratio is greater than 1, we will call it as a deep foundation. Now further, we can classify the shallow foundation in mainly four categories. The spread or isolated footing, this one, in this case a column is resting on a single base. Combined footing, in that case, we in a single base we can rest two or more columns, and it is used where we have the space restriction, or we have the soil properties are defined in horizontal direction. In such situation, we can use the combined foundation. It may be a rectangular, or sometimes it may be also trapezoidal. And strip footing we generally use for your construction of boundary walls, like in such cases. And raft or mat foundation is basically where when the soil bearing capacity is very low, in such situation a whole raft of the area is constructed a single base, and above this base multiple columns are resting. So so we can classify the shallow foundation in four category: spread foundation or isolated footing, combined footing, strip footing, and raft or mat foundation. Now, while we can use in map out questions, you may have seen that the one question is there, that in which situation we should consider shallow foundation, or in which situation we should consider your deep foundation. Now, shallow foundation we will consider when the structure is relatively light to moderate. So the comparison is like that. So if we have a small residential building, in such cases the structural load coming Q for suppose this one QR, and this is for a tall building, suppose this is QT. So QR is much less than the QT. So in such situation where the structural load is light and moderate. So in such situation, we can use the shallow foundation. If the bearing capacity of soil is greater than 100 kN per meter square, that means if the subsoil strength is greater than 100 kN per meter square, in such situation we can use your shallow foundation. If the depth of the hard strata is less than 3 meter to 4 meter, we can also use your shallow foundation. That means suppose in such depth, in a shallow depth, we have the hard stratum of the rock is present. In such cases, we can directly using a shallow foundation, we can shift the structure load to the subsoil. In such situation, also we can use the shallow foundation. When the site is not prone to deep settlement or scouring, that's mean if the soil present beneath this structure, where the subsoil is not going to subsequent or higher settlement, that's mean if there is no peat kind of soil or the expansive kind of soil is not present, in such situation we can also use your shallow foundation. And in cases where we need to construct need to faster the construction for relatively light to moderate structural load, we can use the shallow foundation. And part of the advantage is that for low-rise building, it is economical. It is simple to design and construct because shallow foundation is resting in a shallow depth. So the design of the foundation system is relatively more less complicated, and it's require also less excavation and materials. That's mean if only suppose is this is the depth of the foundation for shallow foundation and it is the depth of the foundation for deep foundation. So in cases DF is much less than the depth of the foundation for in this case. So in this case we need to excavate only these portions. If we excavate this portion, we can construct the shallow foundation. But in case of your deep foundation, we need to excavate the whole length. It may be your 10 meter, 15 meter, or more. Or in case of shallow foundation, it is maybe 3 meter to 4 meter. So in such situation, we can use your shallow foundation. Now we can further classify the deep foundation in mainly three categories based on the structural elements. That mean what are the structural element we are using, that we are a cylindrical shaft we are using, or we are using a like well kind of structure. So depending on this, we can classify the deep foundation in as a pile foundation, fire foundation, and well foundation. So this is the structure superstructure load, that is a load is coming, and this is known as the pile cap on which the superstructure is resting. And below this we generally use cylindrical, square, or rectangular vertical members which transfer the structural load to the subsoil, is known as your pile foundation. And keep in mind that always in pile foundation we generally use a pile cap on which the superstructure will rest, which doesn't use like this is a pile and we doesn't rest the structure in such way. We always provide a pile cap, and above the pile cap we will rest the superstructure. Similarly, in case of wire foundation, we generally use in the case of your bridges. Here, a large diameter cylindrical shaft is resting on a firm stratum. This is a firm stratum. Above this, a large cylindrical uh, this diameter. If this is a diameter D, and in case of pile, this is small d diameter, then the diameter for the pile is much more greater than the diameter of the piles. And also in this case, the above the pile foundation pile, we use a pile cap, and above this, the structure is resting. And the third category, that is known as well foundation or castle foundation. In this case, we generally create a cylindrical hollow space. This is a cylindrical hollow space, and below the space, at the tip of the cylindrical hollow well, we generally use concrete to seal it, and between the empty space between the cylindrical well, we generally use the sand to fill it. Above this, we lock the with a cap, well cap, and above this the structure will rest. So these are the three type of deep foundation we generally use: the pile foundation, fire foundation, and well foundation. Pile foundation generally used for your high-rise building, or any case of nuclear power plant in such situation, and fire foundation generally or well foundation generally used for your bridges, this kind of structure. Now why we the deep foundation is suitable, the deep foundation is basically suitable where the soil bearing capacity is very poor. That means suppose we have a superstructure above the ground level, this is our ground level, and the soil and the hard stratum, this is hard stratum, it's resting far below it, and the soil present, this is the subsoil zone, and the bearing capacity of the soil is very less, that is generally less than 100 kilonewton per meter square. In this case, we need to transfer the load to the shallow foundation will not work. In this case, we need to transfer the whole load to the hard stratum. In such situation, we will use your deep foundation. Similarly, if the foundation depth of the hard stratum is present greater than 4 to 5 meter, in such situation we will also use your deep foundation. And if the site is subjected to a heavy uplift, lateral loads, or expansive soils, in such situation also we can use deep foundation. Uplift means suppose in bridges or there's a uplift pressure, that's mean the cylindrical member has a tendency to go upward, or there is some lateral load is there, that's mean earthquake or wave action is there. In such situation also we will prefer deep foundation than the shallow foundation. And advantage of this deep foundation are that it can support very heavy loads, that is much more heavier load than the shallow foundation can take. It is effective in poor soil condition, that means the soil has a very low bearing capacity. It basically minimizes the differential settlement, that's mean as we are resting the whole all the piles on the hard stratum, so the settlement occurs at the bottom, or the total cumulative settlement will be same for all the piles. But if we use a shallow foundation here like this way, and the soil properties is varying, suppose up to this zone a soil property is uh, suppose x property, and here is a different properties there. So in this case the foundation will settle differently, so the chances of differential settlement in case of pile foundation of the deep foundation is very less, and it is also useful in difficult terrain. So in such situation you can use the deep foundation. Now if we compare that why in which situation we should, or what the situation where we should prefer shallow foundation or deep foundation, so we can summarize it in such a way that if the soil bearing capacity is greater than 100 kN per meter square, we can use your shallow foundation. If the bearing capacity is less than 100 kN per meter square, we can use your deep foundation. Now if the load is low to moderate, that means for small residential buildings, small structures, we can use shallow foundation. If the structure is a high rise building, bridges, like heavy load structure, then we can use for go for deep foundation. If the hard stratum, that's the rock stratum, is present in between 3 to 4 meter, we will consider shallow foundation. If the rock stratum is present beyond 4 to 5 meter depth, then we will go for deep foundation. Similarly, in case of what we want to reduce the construction cost, then we need to go for shallow foundation, and the construction cost for deep foundation is very higher. If the soil is dry and stable, site condition is dry and stable, that's mean no expansive soil, no undermining, or and the water movement is less. In such situation we can consider shallow foundation. But if the site condition is problematic, like marshy land or submerged land, waterlogged area, in such situation we will prefer the deep foundation. So the example for application are residential buildings, small offices, and also in deep foundation we can use for skyscraper, bridges, and industrial structures. So this is the end of the lecture 1. Thank you.